Yes, we've heard amazing things happening in AI and robotics, and I think over the next few decades it's likely to transform every aspect of society. And so it behooves us now to think about like what kinds of changes we want. So I'll just kind of give a brief sort of overview of sort of like what things are happening, what trends are, and what some of these ethical and social issues are. To get a sense, sort of to quantify the scale of the sort of tsunami that's coming, it's nice to look at the economic value. So McKinsey very recently did a report analyzing the likely economic impact of various technologies. If you add up the AI and robotics over the next 10 years, they are likely to create at least $50 trillion of additional value. That sort of compares with the United States yearly GDP is about $18 trillion. So this is a massive, massive economic force. That's leading to huge amounts of investment in this area. Venture Scanner, which sort of tracks a bunch of venture firms, is now tracking 1,630 AI startups funded at the level of $12.2 billion. A couple days ago, the head of SoftBank announced that he's working on a $100 billion fund driven especially by superintelligence. The head of Baidu is pushing China to start an Apollo Moon program, a program of that scale, to develop the China brain, a very powerful AI in China. I think what's going to happen is we're going to see these changes coming in three waves. The wave that we're in right now, I like to call the AI economy. That's basically taking processes that we do today and looking for the low-hanging fruit. Where are the places that we can automate and make things more efficient? And we're just seeing that in every area of the economy. Certainly in manufacturing, but none of the jobs are safe. There's a bunch of little startups doing legal assistance. We've heard about things in healthcare, certainly in transportation. So it's a really massive, full societal change on the economic side. This leads to a number of potential challenges. The ones that a lot of people are talking about are technological unemployment. What do we do with all the people whose jobs are automated? Maybe they shift to new jobs, but there's a lot of issues there. Potentially increasing inequality. There will be the robot haves and the robot have-nots. Those who own the robots will have a higher multiplier in the rate at which their wealth grows. And there's the ability to manipulate populations and create propaganda much, much more effectively. What is that going to do to our society? Sort of the second phase, which is just sort of starting now, but it's likely to speed up as well, is the AI military. All the powerful countries in the world are now working on military drones, working on robotic soldiers, working on autonomous gun turrets. And so we need to figure out, what are the rules of warfare with these new weapons? There's a big movement in Europe right now to try and ban lethal autonomous weapons. But a number of countries already have them. So in the US, there should be a human in the loop before making a decision. In other countries, that's not true. There's a potential for robotic terrorism. Once you have robots fighting rather than people, that may decrease the barriers to war. And so the whole warfare balance in the world may be dramatically shifted. And then finally, over the longer term, every aspect of society is likely to be changed by these technologies. We should see new forms of voting, new forms of laws that cover these technologies as well as the existing human things. And we may start to see AI systems participating in governance and simulating the effects of different laws on society. And so those introduce a whole bunch more questions. So to kind of get a sense of some of the issues, it's nice to look at what's happening right now. We're just at the very beginning, I think, of these technologies coming into the human sphere. And sometimes the systems which work wonderfully in the lab have challenges when they're in the world. So it's good to look at a few examples just over the last few months to kind of get a sense of some of what's happening. A couple miles from here is the Stanford Shopping Center. Over the summer, they had this nice little robot, a security robot that would roam around and look for trouble. This young toddler thought that robot was really, really cool and ran over and tried to give it a hug, and it unfortunately ran over him and kind of gave him a sore on his arm. Didn't hurt him too badly, but the robot company and the Stanford Shopping Center said, oh, we gotta think this through. We didn't expect that use case. And so that was a bit of a challenge. We heard some wonderful talks about autonomous vehicles and how that's going. Farmers have had autonomous tractors for many years. And most farmers do not drive tractors around anymore. They sit there with their little remote control and the tractor does its own thing. But the tractor's not interacting with other tractors or with people. So that was a much easier case where getting the tractor to work in the lab pretty much ensures it'll work in the world. Autonomous vehicles, as we've been hearing, that run on actual human streets have a bunch more challenges. And we've started seeing test vehicles. Tesla, of course, has Autopilot. Google's been driving their autonomous cars around here. Over the summer, we started seeing the first autonomous vehicle accidents, one of them fatal, unfortunately. And people are starting to think, oh, okay, what are the rules here? How do we want to guide these? And some ethical issues are coming. I like this domain because it's a fairly constrained domain. We know the rules of driving for humans, and so we can think a lot about how do they extend to autonomous cars. The philosophers, ethical philosophers, have been thinking for years about something called trolley problems, which are sort of simplified ethical questions. And the sort of autonomous vehicle version of that is your autonomous car is driving down the freeway, there's a truck in front of it with a load on it, the back door of the truck opens and the load falls on the freeway, and the car has to decide, do I crash into the load and perhaps kill the passenger of the car, or do I go to the next lane where there's a motorcyclist, I run over the motorcyclist, but I save the driver. Which choice should I make? Somebody in a lab somewhere has to write the software to do that. How do they do it? What are the ethical bases? Does it matter who the motorcyclist is? Does it matter who the passenger is? Can some car company say, Hummer says, we always prioritize the passenger? And will that affect people's choice of car? If the car's rules by which they act are known, will other cars then take advantage of that? Like, if I know that car always acts conservatively and lets other cars come in front of it, well, I might just cut in front of it. So we have all kinds of complex dynamics there, a lot of issues about liability. When an autonomous car gets in an accident, whose fault is it? Is it the driver? Is it the car company? Is it the person who wrote the software? So big challenges there, which is being sort of sorted out as we go forward. And it's not just cars with cars, there's also issues with pedestrians. So Google has been sort of driving their little autonomous cars around the streets here. If you live here, you've probably seen them. And they're very conservative. They tend to drive slowly, and they really don't want to hit any pedestrians or anything like that. And so if the car is coming along, the pedestrian looks like it's about to step in the road, the car will stop. Well, pedestrians think this is kind of fun. So they've invented this thing they call autonomous chicken, which is the car comes up, they act like they're going to go on the road, and then they don't. And then the car starts up and they act like they're going to go on the road, and so you sort of get a little game going. So people say, well, what do you do with that? So somebody proposed putting sound cannons on the top of the cars to blast the pedestrian if they don't get out of the way. Another situation that just happened a few months ago is a British company called Cambridge Analytica. Steve Banyan is on the board of this, and the company is claiming that they model personality types of people in different countries, and that they had a big impact on both the Brexit election and on the Trump election, and they're about to affect the Australian elections. And there's controversy over how much impact they really had, but they are saying that they have a personality model built by machine learning and AI, trolling, social media, of every citizen in the United States. So we want to think about, hey, what does this do to our society? Another cute example, Amazon has the Alexa, which is a little voice-controlled box that many people have. I've got one, really great, works well. They've got the user interface going well. Apparently kids absolutely love this device because they can talk to it and play to it, and if you ask Alexa, she'll tell you jokes and things like that. Parents are a little bit wary because Alexa does not care if you say please and thank you. And so the kids sort of shift into this mode where they become very commanding. Alexa, give me that! Alexa, do this! And then they start doing that with people, and the parents are like, no, you have to say please and thank you. There was a very funny incident that happened a few weeks ago where a little girl just loved Alexa, and she said, oh, Alexa, will you play dollhouse with me? Alexa gave me a dollhouse. And the default Amazon had was that you could use Alexa to make orders for you. And dutifully, Alexa ordered a $140 dollhouse to this little girl's house. So that was kind of shocking. The parents thought this was really strange. And the local news got a hold of the story, and it had the little girl on the news station And they said, well, what did you say? And on the news, she said, Alexa, get me a dollhouse. Well, people who were watching the news channel that had Alexas all got that, and dollhouses were flying around the country because of this. So unexpected sort of social behaviors can emerge if we don't think through the consequences. Amazon now, I think, has a 4-digit code that you have to do before it'll actually do an ordering for you. Unexpected behavior of lots of systems. You may understand the local system, but the way they interact can lead to unexpected behavior. We see that in the financial markets. Right now, over 50% of all trades on financial markets are high-frequency traded, totally automated systems with no humans involved. And in 2010, the Dow Industrials crashed by 9% in 36 minutes in this thing they call a flash crash. And then it very rapidly came back up. $1 trillion of value was lost and then regained in that process. And to this day, people don't understand the full dynamics of it. So something about the interaction of these not very smart, but kind of smart systems, each trying to model one another, led to this very large collective behavior. The military side of things, it was just announced a month or two ago that ISIS is taking commercial drones, and they've added a little attachment thing which allows them to drop hand grenades from these commercial drones, and they've started using it as a weapon in war. And so that opens up, as drones get better, today I think they're still using remote controlled drones, but in the lab, lots of people have used deep learning to have drones that are autonomously navigating through territories. We have deep learning facial recognition, and so we should expect to see autonomous assassination bots before long. So we're going to have to think about, what do we do about that? How do we respond to that? Today we have not fully figured out the technology of developing correct technology in our normal world. So we have serial software that still has all kinds of bugs, memory leaks, dangling pointers, conversion errors, parallel software, distributed software that has additional bugs, deadlocks, and race conditions, security bugs that are really going crazy over the last year, people not using encryption correctly, having buffer overflows, leading to all sorts of security issues all around the world. And then hardware bugs where the abstraction of the hardware isn't working right. A few that have gotten high profile recently are rowhammer, drammer. These are things where if you access memories in a computer, a phone, or laptop, or a tablet in the right way, that you can flip other memory bits and break encryption. And so all that's happening with today's ordinary hardware. Once we start getting autonomous systems everywhere, a whole bunch of new issues come and new technologies will be needed to ensure that they behave properly. Lots of systems that we heard about today are being based on machine learning. Deep learning is the hottest and most exciting form of machine learning. The trouble is, when it learns a system from some data, it's totally opaque. You don't know what the rules it has in it. So if you built an autonomous vehicle for driving using deep learning, you can't predict how it's going to behave in some new unknown situation. So that's a challenge for how we manage it. It turns out there are also ways to create what are called adversarial examples. So you have a classifier, say, that distinguishes dogs from cats. Turns out there are now automated systems which can adversarially take that network and create things that look like dogs, but the system will believe with high confidence are cats. If we build systems which are goal-driven, today when you write a piece of software, you say what happens at each stage. Where we're moving, the next generation of AI systems will give it goals, and it'll figure out the best way to achieve those goals. Turns out goals have to be written very carefully, or else they have unexpected consequences, unintended consequences. They will create sub-goals which may not be positive and may not be what you were thinking. As these systems are integrated into society in general, we're going to need to create governance. We need to create rules like speed limits for cars. And the choice of those rules will also be subject to optimization by algorithms. And they will look for ways to, they'll look for loopholes, look for ways of getting around those. And so we're going to have to create our rules and our constraints on these systems very, very carefully. And finally, if we have collective, lots and lots of AI systems that interact with one another, they can behave in ways that are unexpected to us. So how do we ensure, as these new technologies are coming at an unbelievable rate, we have a huge economic driver that's pushing them. So they're going to come, and if it's, let's say the US decides, oh, this is too dangerous, we don't want this, we stop. Well, Europe is not going to stop, China's not going to stop. So we're in a situation where it's pretty inevitable that these technologies are coming. How do we ensure that they give rise to human, they're beneficial for humans? So in 1943, there was a psychologist, Abraham Maslow, just a couple miles from here, and most psychologists at that time were studying rats. He thought rats were boring. He decided to study his professors. He thought his professors were like really great people, doing their passion, living really well. He wanted to see what they were doing to do that. And he created this thing he called the Maslow hierarchy of human needs. And it represents what are the characteristics that people need in order to really thrive in their lives. And he kind of viewed it as a pyramid. The base of the pyramid is physiological needs like food, water, shelter. Above that are safety needs like not getting attacked on the way to work, not being in the middle of a war. Above that are social needs for companionship, for love, creating families. Above that are esteem needs where you feel like you can do a job that is important, that you do well. Above that are self-actualization needs, which is sort of your life purpose, your meaning, things that you do in the world that really express something, maybe creativity. And then he found a few people, he didn't find a lot of people that had another top level, which he called self-transcendence, which is a sort of connection with something much larger than themselves and contribution on a much larger scale. And so, this is sort of the human as we understand it. A lot of refinement has gone into that since then, but it's a nice framework to think about it. And we can think about these technologies are going to impact every one of these levels. And I think they can impact it in either a positive way or a negative way. So here's the Maslow hierarchy dystopia, where at the base level of the physiological needs, we have technological unemployment, inequality, scarcity. Above in the safety level, we get cyber terrorism, robot warfare. The social level, we get social disconnection, people tied to their phones rather than other people, virtual reality, pornography. The esteem level, maybe we have human obsolescence, greed. Above that, maybe we have addiction, and maybe a loss of meaning. So that's the downside. But if we make the choices properly, then hopefully we can create Maslow's hierarchy utopia, where we create technological abundance. We're going to have unbelievable increases in productivity that will be at a level to support everybody on the planet at the levels of the highest people today. Total elimination of drudgery. If robots do the jobs, any job a robot does is not a job I want to be doing. So let the robots do it. Let's let people do things that people love. Safety, using some of these new technologies, something called smart contracts, there's a potential to create guaranteed interacting systems and negotiations between countries and regions that potentially can lead to a much greater level of peace. Social level, new tools for fostering human connection, tools for people to feel like they're thriving. The esteem level, new kinds of creativity, new tools for creating beauty, self-actualization, things that you contribute to people in a way that much greater than was possible before. And maybe at the transcendence level, networks of sort of inspiration and sort of helping the world as a whole might be possible. So a couple months ago, there was a fantastic meeting called the Beneficial AI Conference in Asilomar. 50 years ago, the biotechnologists got together at Asilomar because they realized that biotechnology was potentially very positive, but also had some negatives. And so they tried to put together principles for biotechnologists to proceed safely. And those have been very successful in the past 50 years. So a group of people involved in AI decided to do this and created a set of AI principles of all the big AI companies, Google, Facebook, Microsoft, and so on, were all there, and it seems like a very positive development. And so I think in conclusion, the future is very bright. We need governance for these systems. We need new ideas about how to build them safely. We need new methods for testing and designing them. And we need lots of new AI startups. And so this is the perfect place for that.